So today we see how we can write the function in the MATLAB. Up to here we have learned that how we can write the script file, means how you can write the program file. But you know that we have the built-in function in the MATLAB, and you once you have the built-in function you can use for your purpose like sqrt, inverse, all such are the built-in functions. But in addition to that, if you wish, you can also create your own function and you can use those functions just like the built-in function. So today we learn that how we can create our own function in the MATLAB. So doing programming in the MATLAB is two different ways. One is you can write the script or you can write the function file. So today we learn that how we can create the functions in the MATLAB. So just like you have the question here, create a script file to construct a unit circle. Unit circle we know, I think. Unit circle means the radius of the circle is 1. This is okay. So we have the radius and this is 1 unit circle. So we have already seen that how we can construct the how we can plot the circle. Here we see that how we can plot the circle with the help of function actually. So if you write the script, then you know that you can write the script like this. Okay, so here is the, you can enter the commands one by one in the command prompt, or you can write the script file. So theta, you can see here, theta is line spacing 0, 2 times pi, 100. This is the new function to you. So see, this is the new function. You have the line spacing. This is the new one, and this means linear spacing actually. And this function can be used for creating the number of points. Like here you have 0 to 2 pi. You have 0 to 2 pi. And between 0 to 2 pi you need 100 points. So you directly write the 100 points. Okay, this is also other way to create the number of points. In earlier cases you have used the colon operator like this. Then you have here you have to use the increment value, and then here you have to use the you have to specify the end points, means okay, last one. So like you can say 0 colon, if you are incrementing 2 colon 10. So starting from 0 you need to go up to 10 and increment is by 2. So you will have 0, then 2, then 4, then 6, then 8, then 10. These are the points you will find. So other way, so how many points you have? 1, 2, 3, 4, 5, 6. So you have the 6 points. So if you are using this function, then what you need to say? You say that 0, comma, you need to go up to here 10. You need, this is 10. And then how many points you need? 6 points. So you can say. So you can also specify that. So this is new function for you, and this can also be used for obtaining the number of points. So this is, if you are clear that you have to generate 100 points, 1000 points, then you can just write here. So in this case you may need to compute. If you start from somewhere else, instead of 0 you need to compute. So here you have direct control how many points you need to create. So that's why here you need to make the comma, because this is the function and these are the arguments. So arguments are separated by the comma. So last value is the number of points, and the second value is the end point, and this is the start one. And remaining we have seen already. So whenever you have the value of theta, you have the number of this is, you have the vector of 100 points, and then you can have the x value, and see you have the radius circle equation, parametric equation, r cos theta and r sin theta, and here r is equal to 1. So that's why you just say that x is equal to cos theta and y is equal to sin theta. And once you have the value of x and y, you are going to use the plot function. This is the function used for the two-dimensional plot, and x and y, and x is equal so that it should look like the circle. And this is also one new command for you. So here is the new commands you have, and this new command is what? Title. So here actually if you wish, you can write the title of the graph. So you can write the title as circle of unit radius. You can say like this. So this will be the title of your plot. So this is also when you go for the title, then within the title, here from here to here, this is the string. So you have to give the string. So you have to give the single string here, and whatever string you are giving as the argument, it will be written as the title of the graph. So this is also one new commands for you. So you have the this is one and this is the two. You have these are the two new commands you have found. Okay, and once you type one by one, then you will have the plot of the circle. So now somebody says that okay, create a script file to construct a circle of any radius and take the radius from the user. Now here we see that okay, we have the unit radius. So unit circle is there, means radius is 1, and if you wish it, then r can be anything, and the values can be, you can ask the user what is the radius of the circle, and according to the radius of the circle you need to construct, you need to plot the circle. So here you need to create a script file for any radius, and this radius you need to ask. So you have to write the statement so that your MATLAB statement asks the user what is the radius you want. So for that actually you have the commands. This is the third new commands for you. And what is this? This is r is equal to input. This is the built-in function in the MATLAB. Input, and whatever you are writing as the argument, this will be displayed. So enter the radius of the circle, just like you want to display like this. So this will prompt you enter the radius of the circle, and whatever value you are going to enter, it will be assigned to the r. So r is the variable which will take the value. So once you type the value through the keyboard, and whatever value, you will see this message, and once you see this message, you are, say for example, you are entering 10 and pressing enter. Once you enter 10 and press enter, then if you display r, if you press r, then r will be equal to 10. So the value whatever you are going to input, the value is assigned to this. And if it says that input enter the radius of circle, and you have pressed enter, then you will see this dialog. And even after seeing this dialog, again if you press enter, then actually you are not entering anything. So you have the null matrix of zeros. So this is considered. So you can enter the numeric value here. Here this is used for the numeric value. And if you want some string, then you have to specify. Here you can say the comma, and you can say input, then you have to write the message what you want, then comma, then you have to specify s. Once you specify s, then this says that whatever you are going to enter, this is the text. It is not the numeric, this is the text. And if you don't specify s, only you have the string, then it says that you have to give the numeric input. So this is the third one new commands for you. Now actually our target is to how we can create the function in the MATLAB. So for creating the function, these are the various forms we have. Okay, here just you learn, this is variable, means the output of function. If function outputs some value, then you are going to assign to this variable. Okay, so you have the single output, you have just one output, so you can mention some variable name here. So here is the function name, and then you can have the argument lib. This is the parameter value you are going to enter. So argument 1, argument 2, these are the parameters. So you can enter the parameters, and once this function completes, then the result will be, whatever is the result, it will be assigned to this value. Here this function is going to return the two different values. Variable 1 means you have one variable, and this is the other variable, this is the other variable. So okay, so the output of function is two values actually. So one value is assigned to this and other value will be assigned to this. How variable 2 will get the value and how variable 1 will get the value, I will let you later. I will explain later. But just for the time being, you should come to know that here is the two. This function is going to return two output, two values. And in this way, you can have any value, variable 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. You can return any number of values. And if you don't want to return, then just name of the function. Just you have the name of the function here. And you have the parameter. Means this function is not going to return any value. This means. So this is important. Function name is very important because whenever you are supposed to call the function, if you want to call the function, then you have to specify the name of the function. So this is the function name. Function name is very important, and here just function name, you can write your function name in your convenience. Like sqrt inverse you have found in the built-in function, and you can write the suitable function name here for the purpose you are constructing the function. So function name is important because once you want to access the function, once you want to call this function, then you have to specify the name of the function. So this is important, and you need to know that how many values are there and what are the type of argument, whether it is the numeric or whether it is the string. You have to remember it. If you don't think that if you are not going to give any input, then you don't specify the argument. You can say that function name and empty braces. There is no argument. You don't require, just empty. Now users can add to the MATLAB's built-in function by, there are two things. You can do the programming. You can do the programming to the function. Means you can write you have the built-in function, and if you wish to add more function, then you have to do the programming and you can write. So it is important actually. Why we need to write the functions? Generally, for your work, you might have observed, those who are in the computer background or IT, if you are doing the programming, you might have seen that whenever you are writing the program for some purpose, and if you don't create the functions, then it will be the very lengthy programs. You may need to write the thousands of lines. And once you have the thousands of lines, and if you are going to execute the program, and if there is some bugs in your program, some errors in your program, then it is difficult to remove the errors. But once you go for the creating the function, so for every task you can create one function, so that if that function has some problem, you can access the function and you see that you can remove the bugs from that function. So this is helpful for doing the modular programming. Means you have the big programs and you want to divide the big program into the smaller modules, and for the smaller modules you are writing the function. Okay. So for your project work, for your research work, you will see that there are a number of, say one module may be the visualization. You want to visualize the data. So you can create one function that will visualize the data, and after that you may want some computing the variance or standard deviations like this, and you may be interested to construct the plots for the pie chart or something else. So you can write one function for constructing the plots, means visualization. You can write one other function for statistical analysis. So this is the way you can divide the larger program into the smaller program, and this is very good practice. Those who are the good programmers, and then they always do like this. So in the main function, whenever you have the main function, you have in other programming like C language or C++, if you have the main function, within the main function only you need to call the function. You just call the function. So you don't require to write the programs like 1000 or more 10,000 lines. Okay? You just need to call function 1, f1, f2 like this, and so that this will look like the modular programming. And it is very easy to communicate your logic. You can say that, okay, for the purpose, first we are going to construct this, after that this, after that this, after that this, and every function you can link according to the output produced by the F1. Then it may be possible that the output produced by the F1 can be the input for the F2. Okay, or F2 is necessary after computation of this. So you have some proper link. But if you make practice to write the functions in your programming, then it is very easy to go for the modification, and also it is very easy to go for the for communication purpose. If you want to communicate this logic to some other persons, then once you have done the modular programming, once you have written the function, then communicating that, okay, I'm doing first this, then this, then this, it is very easy. And during the execution, if you have some bugs, then also it is very comfortable. You will find that, okay, in which function is going to create the bugs. Say if you have F2, you have created for the visualization, so up to here your visualization works. But if this is the function, say F3, for some different purpose, and it is after that, if your program is stuck here, then you come to know that, okay, the problem is from the F3. Then you can go and debug, and this is the good practice. So always try to write the function in the program, and this will provide you the modular programming. Means you have divided the complex task into the smaller task, and smaller task, for the smaller task you can write the function. It is also, you may have that, okay, same function may be required many number of times. Like if you are having some, if you are computing some series, so you may have some computation of the square root of I can be equal to 1, 2, 3, like this. So 1, then square root of 2, like this, then 3, and so on. So every time you don't require to write the script for computing the square root. You have built-in function. Like built-in function, you have, if you have your own function, you can just call everywhere. The same code, if you want number of places, then it is also beneficial. If you have written the function, then for the same purpose, if you use some in some other parts of your program, then you can use the same code with the help of the function. So this is very helpful. Okay, and you remember that what if whenever you are going to write the function, if you have the function, so within the body of this function, if this is the area of this function, means your function works from here to here, then whatever variable is here, say you have the x or y, these variables are effective only this environment, and these are called the local variables in the. So if you have defined the variable within the function, these are the local variables. And if in your workspace, if you have the variable x and y, then this variable and these variables are different, because this is local. This x and y are local for f, and this x and y are in your environment. So this will not affect, because this is the, it is working locally. So you have to remember that whatever you are going to define within the function, whatever variable you are using, these are the local variables for you. Okay. So if you are changing, say if you x is equal to 10 in your workspace, and if you say x is equal to 5, then it will not affect this. It will remain 10, and you are working within the function. So it cannot create, and this function cannot accidentally change the or destroy the data in your workspace. So you have to remember. So you don't worry whether the variable is available in the workspace or not. Whatever variable you want, you can use within the function. Okay. Now, whenever you are going for some computation of some task or execution of some project, then always you have to start. If you want to write some bigger program, okay, and for your research purpose, and you want to implement to see the result of your methodology, then you need to write the program. Either you can do programming in the MATLAB, or you will do the programming in some other language, or you will be using some tools. If there is no tool available, you have to write the program sometimes yourself. So whenever you are supposed to write the program, then always you have to start from the, you can write down the steps in your paper, what you want. You have problem definitions, means what, for what you are going to write the programs. Then again, you can generalize and decompose the problem definition, identify the subproblems, and these are the subproblems actually for which you need to write the function. So you have the complex programs, complex tasks. Out of this complex task, you have to decompose the complex task into the subtask. So the bigger one can be have the number of smaller tasks, and these smaller tasks are the functions. You can write the function, and you can interlink these function one by one according to the your scheme or formulation. So this will be the helpful. Means you need to develop the algorithm. Once you have decomposed, then you can say that you are collecting the data, then you are going for visualization, then you are going for the data cleaning, then you are going for the experimentation, actual experimentation, then analysis. So this is the way you are going to develop the algorithm. And once you develop the algorithm, so you are going to data cleaning. So whatever methods you are going to use for the data cleaning, you have to specify here in algorithmic function. So this is the way you can write the algorithms. Means whatever is your methodology for solving your research problems, you have to develop some algorithm, and that algorithm is actually you need to implement in the programming language. And for implementing in any programming language, actually you need to see that what are the subtasks in this algorithm, and for those subtasks you need to create the functions. Means you have to do the modular programming. Then it will be very easy to write the bigger program using this. Otherwise, if you write the programs one by one, statements one by one, then it is very lengthy and it is complex to debug the programs. Then finally, once you have the algorithms, then you have to change the statement of your algorithm in any programming language. Like this is the MATLAB. If you know the MATLAB, you can change the statement of your algorithm into the programming language, and hence after the implementation you can run and debug, you can test and debug and run the code, you can do the experiment, you can do the profiling work like this. But see that after 3, if you go for the 4, so once you have written the algorithms, algorithm is simply the steps. Okay, you are following here up from this, then this, then this, then this. This is the steps you are going to mention. Okay, so once you have the steps, once you have the algorithm, then you need to implement the algorithm in your programming language. Generally, when you write the algorithm in your research paper for the communication purpose for publications, then you have to write the algorithm in some technical form. So you just not write like this: input, taking input, then data cleaning, then this. This is not the algorithm. Generally, you people mention like this. Algorithm means it should have the, you can use the pseudo code. You may not use the actual syntax, but you can use the pseudo code for defining the algorithm. So you have to write the proper algorithm, and once your algorithm is systematic, then it will be very easy to change the statement of your algorithm into the programming language. But remember that each and every statement of your algorithm must be deterministic, clear and deterministic. If your algorithm, statement of your algorithm must be clear, every statement, and unambiguous. Clear and deterministic, you can say that, clear and unambiguous. Okay. So unambiguous means deterministic. So this means you can say that add A or B to C. So add A or B to C, this is not the deterministic statement. You cannot implement this statement in any programming language. So you have to clearly mention whether you want to add B or whether you want to add A. So you can say either A plus C or you can say B plus C. Add A or B to C. So either mention this or this. You cannot say that computer will take decision, add A or B to C. You will not find any programming language where you can implement this statement, because this is the non-deterministic statement. And there is no programming language which can handle the non-deterministic programs, non-deterministic algorithm. They cannot execute their non-deterministic algorithm. So that's why your statement of your algorithm must be deterministic one. Then you will find then you only implement the statement of your algorithm in any programming language. So once you have implemented, then you can run and debug, and then you can do the profiling work, and you can report the answers. You can do. Now the main task comes. So we have seen that why we have to go for the function in the MATLAB, why we need to write the function. And you see that once you have the skills to write the function, then the complex task you can divide into the smaller one, and it will be very easy to manage the things. So that's why we need to write the functions. So for creating the function in the MATLAB, you need to remember this syntax. This is the syntax, and this is the function, and this is the key. And this is the keyword, you can say. Means you have to write the function. Once your statement begins, once your script file begins with function, then computer comes to know that okay, you are writing the function. So this is very important. So you have to write the function. Then here you have to mention how many values your function is going to return. So you have to mention the out variables within the square bracket. So you have to list the variables, how many outputs you want. Say if you have 1 2 3 5 outputs, so you mention the 5 variables names here, so that those variables can be assigned to the values. Okay, and then you have to equal to sign, means you are going to assign the values, output of the function, whatever the output of the function, to the variables. So that's why you are going to assign the output to these values, to these variables actually. And then you know that you have the input variables, these are the arguments, you have the arguments, possibly it can be empty also. And this is also important, function name. But function name is not unique, you can write of your own choice. If you want to say that I wish to write as the something like this, PhD test 1, so you can say PhD test 1 is the name of the function. So you can write the function name in your choice, but you should write the name which is the relevant to your task. This is important so that you can remember for what purpose you have constructed the function. Now you know these things. This is the percentage sign, you know, comment sign. Now within, once this is the function definition you have, and after that you have to write the series of, means you have to write the set of commands here, just like you have written the script file. And here actually, at if you have say if you have some variables here, means your function is going to return the value, like a and b are two variables for which you are going to return the value. Then once you are writing the body, then in your body one statement must be like this: a is equal to something and b is equal to something. Means you have to assign the values so that this function is going to return the value to the variables. So if you want that okay, your function is going to return the values, then within the body of the function you must specify the variables names, and what value you want to return you have to specify here. So body of the function is important, and this is the note is given already. One statement in the body of the function should be of the form output variable is equal to expression. So what value you are going to return, this you must mention, and here you must have the variable name. So variable a is equal to this, b is equal to this, like this. So how we can write the function? So for writing the function, you have to begin with the name. Begin with the word function. This is very important. You cannot change. So this is important. And then you can possibly you can have any number of variables. Then this is name is for your choice, and whatever the number of arguments you want. Then you have to write the function definition here. Means you need to write the statements of the function. Okay. So see, we need to construct this circle. So write a function that construct a circle of a given radius here. So here we are going to write the function. So function, this is the function definition, you know, this is the function definition. Your function will begin with the function name, word function, keyword, this is the keyword, you can say function. So you must begin with the function. Then this is the x and y, these are the outputs. If you want some output, then you can give the list the variable names. And this is the name of the circle. So I have given the name my circle. So this is the name of this function. So whenever I want to call this function, I will call by the my name. And R is what? I want that user should input the radius, okay? Or you can call the function by supplying some radius, okay? So you have you might have in the workspace, you may have some values, say for example 10, and then you can call by my circle 10. If you say that my circle and 10, it means r is equal to assigns to the 10, and you are interested to compute the you are interested to plot the circle of radius 10. This is simple. So you can, once you call the function, then it is important that how many arguments is there. You have only one argument, so you must mention the argument name. So my circle, this is the name of function, and what value you want to supply, this must be specified. So you can remember. So for calling the function, you can do like this. And then every rest of the things are same. You need to compute the number of points here, 100 points, say for example, and LIN space means linear spacing, equidistance points will be created between 0 to 2 pi, including 0 and 2 pi, like this. So, and x is equal to r cos theta. Now r is the radius here, r is the radius, and then you are going to plot x and y, and then x is equal, and you are giving the title of the graph, so circle of radius r. So this is the way. Now once you have written the function, then what you need means this is just like the script file you have written. This is the script file just like we have created earlier, but this is the special script which begins with the name function. And once you begin with the name function, means you are creating the function. Okay, so this is important. One thing is more, you don't put begin, means for start, begin and end. This is not allowed. However, you can just, function is the start one, and if you wish that okay, end is the optional, at the end of the function definition, and at the end of the line you can write end. But if you have the only single function, if you don't want to write end, then you can omit, it is optional. But function and end means this end is for this function, means this function is going to end here, and this is optional. And don't do mistake, you cannot write braces like this. You cannot say that okay, you are enclosing the body within the function by enclosing in the braces, curly braces. No, this will not work. You just say function, this is the begin, actually just like it behaves like begin, and this is the end. Optionally, this is the optional. If you have only just one function, you can have the only this is optional. You may write or you may not write. You can remember. So you have written the statements of the script. Now you want to save. So until you save, you cannot call this function. So whenever you save, then actually whatever you have written here, my circle, your file will be created by this name actually. So unlike the other script file, whenever you have saved, you can give the name of the script file. But whatever name is given here, if you save this function, then whatever you have mentioned the function name here, your script file will be by this name actually. So your script file will be of my circle, okay, .m. So your script file will be created like this, my circle.m. So automatically, you don't require to give the name, you automatically my circle.m will be written. So whenever you push save button, and you will find that my circle.m. So .m already given, my circle is the name of your function. So this you need to remember. Whenever you are writing the function, you have to begin with the function name, word function, and you have to write the function name. And once you save, you have to save the function by the same name. And it is actually automatically this name comes once you save. Okay. So here, like you have the my circle, your script file will be of this name, my circle.m. So save the file with the same name as the function. So till now you have seen that how you can define the function and how you can use the function. Okay. So for executing this function, means for calling this function, you can do like this, like r is equal to 5, radius is 5, and you say that my circle r. And remember that your my circle is going to return the two values, x and y. So that's why you have mentioned the two variables names x and y. And this x and y you don't require to name the same because you are unaware of the variables used within the my circle. You can say xx, yy. This will also valid. Or you can say that x1, x2. This is also valid. Means you don't worry to remember what was the name within the function. Whatever you wish, you can give. Whatever variables you want to use in your workspace, you can give the name of the variables. So you can call by this. So in the command prompt, once you write this is like this is the variable, two variables. If you have the two variables, you can mention the two variables name, my circle 2.same. And if this function is going to return two values, and if you are mentioning only one variable name, say if you just say that xx is equal to my circle and to find, say for example, or I may say that 20, my circle 20, and you press enter, then xx means the whatever be the first variable name, you remember that you have written the list of variable names, variable 1, variable 2. So whatever be the variable, first variable values, it will be assigned to xx, and the second value is not going to assign because you have not specified the next variable. So if you wish to use only single variable, you can use this. Otherwise, if you want to use all variables, you can use. So you can also give the expression that evaluates numeric value. So 2 times 3 minus 1, like this, and this will be the 5 actually. So you can also have the expression which can evaluate some values. So within you are calling, and if you don't want to use the variables, just you want to see the plot, you just type. You don't require to mention the variable names here x and y. You don't require to mention two variable names. Just say that my circle and the value. Means you are not interested with the output. You are just interested to see the circle, how it will look like. So these are the various ways you can call the functions. Okay. So like this, you have to begin with the function. This is fixed keyword, and these are three variables name you have, and this is the name of function. And how you can save this function? By using the motion.h, because the name of the function is motion. So you have your script file will be motion.h. Whenever you are using the, say you have only single function, single output, so you have only one variable theta, then, and this is the name of the function. And how you will save the file with, then you have to save the file by name angle th.m. So angle th.m. Then function theta. See, if you are going to return only one value, then you don't require to include in the square bracket. Just you mention variable name and theta xyz, and this will be saved as theta.m. See, whatever is there, whatever. And here possibly you can also say like this, empty. If there is no argument, means variable name is empty, and you can do like this. You are not going to return anything, and your circle.m, here is circle. And if you don't have any variables, if you don't want to return any variables, okay, means any output, if your function is not going to return any output, then better is to write like this, function, it is fixed. Then here you don't require to specify the variable then equal to sign, and see that equal to sign will not be here, because equal to sign means you are going to assign the output to these variables, and here you are not going to assign the output. You are not going to assign. If you make equal, it means you are going to assign the value to the function, but you are not going to assign the value to the function. So you don't mention the equal to sign. If you don't want to return any value, just say circle. This is the name of the function, and if you have some argument 1 or 2 or 3, and then you can save the file by name circle.m. This is okay. So like this, if you want to compute the factorial of some integer, then you can write a function. So function You have to begin with the function. Okay, you have to begin with the name function. Then you have to list of variables, your output. This is the output. So whatever will be the factorial of k, it will be assigned to the value n. So this is the factorial, k is the input. So how you can compute the factorial? These are the commands. You can write the documentation, and I know you know that the best practice is what every time you create some function, you need to write the documentation. And you have seen that, just like you said, doc sqrt, built-in function, and you see the documentation. If no documentation is there, then if somebody wants, then you will not be able to see the documentation. So it is better to write the documentation, and also this is useful for the future reference. You will come to know that, okay, for what purpose you have constructed this function, and what are the various parameters, or what are the inputs arguments. So see, if the k is less than 0, means you are not going to find any factorial value. So you can generate the error. So this is the string. So n will take. So this is the variable. What value will you can assign? So remember that I told you that whenever within the body of the function, this is the body of the function. Within the body of the function, one statement must be of the form variable names like this and some expression. Here the expression. Okay, so you have the expression, and here you say that you are checking if k is less than 0. Later we will see that what we mean by the if condition. Just for the time being, you should know that, okay, if condition means your computer is going to check whether the value of k is less than of 0 or not. If k is less than 0, then it will return the value true, and once this is the true, then you are going to assign this string to the output variable n. And if this is not less than 0, then this is false. And once this is false, then you are not going to execute this statement. You are going to execute this statement. So if this, then this, else if. Again you have the condition. If k is less than 2, then you know the answer is only 1. Otherwise, if k is less than 0, then you have the error. If k is less than 2, then your answer is 1. Okay, and otherwise, if k is more than or equal to 2, then you have to compute like this. So you know that how you can compute n is equal to 1. And okay, for time being, you understand the for loop means you are going for the iterations. Actually, for j is equal to 2 to k, means from 2, 3, 4, 5 up to k. And what you are going to do, every time you are entering, you are going to multiply. Like you have n is equal to 1, then you have the 2 next. So you have your j is equal to 2. So you are going to multiply n is multiplied with 2. Whatever be the result, you are going to assign the n. Then again will multiply 3, and this is the result. N will become 2 into 3. Then again you multiply n with 4. Like this, you are computing the factorial like this, and you are assigning to final value is going to assign to the n. So repeatedly you are going to modify the value n, and you are good n. So this else, this and is for this if, remember. So you have written the function, and then you can call the function. Our task was to write the function for the factorial, just like we see the implementation of the factorial. So I can show you demo. See that we need to write the function for the factorial. So I have already cut and paste here, and I have saved by the name my circle. So this, you know that the file is saved by the name my circle. So this is the things. So this is just like this is the script file. Whenever you want to create some new function, then you have to say new, and this kind of editor will open, and you can just begin like this. So this is the script file you have, and this, you know that this is the keywords which begins with the function name, and you are going to return the two values. You have the two values x and y, and this is the name of the circle, my circle. Okay, now you have the theta. Theta will get the vector of 100 points. So you have the 100 points here. So theta will have the 100 points, and whatever with the vector theta, you are going to find the value of x, and from where you will get the value of from this input. This is the input. And then you are going to go for the plot xy and x is equal, and title you have given circle of radius r. So they so how you can execute? So for execution of this, and I have already saved. We have not done any modification, so I don't require to save it again. It is already saved. And how you can call this function? So by the name of the function you have to call my circle. Okay, my circle, and then you can specify the parameters value. So parameters, you have to input the radius. So you can say that I'm going to give the value 10. Okay, and see here, r will get the 10, and this function will execute. And you see here, this is the function. This is the plot of the circle. So this is the circle of radius 10, and here you can see the title circle of radius r. This is the title circle of radius r, and you can see. Okay, and now see, if you come to the command window here, you will see these values, and say that I have just, you can start from the, you are getting the value from the theta is equal to 0 to this, and then x is equal to cos 0, whatever be the value, then you are going to multiply with r. So your column 1 you will have the 10 and this. So cos theta means cos 0 means you have the 1, and then you are going to multiply with 7, so you have the 10. So from you have the how many points? You will have the 100 points. You can see the 100. You have the 100, 96, column 96 to 100. So this is the 100th value. Now see, you have just one output. You have the value for the x only. And this, since you have not mentioned the any variable's name, then by default variable is what? Ns, ans. So answer is storing the first variable values here, like this. But if you do like this, if you call the function like this by saying that say x comma y and this, just say like this and press enter. Again you are getting the circle. Circle is plotted, and see that here you can see the values. Here you have the two different values. From where? Okay, so this is, we have specified x and y. So you will have the values for the x and y, 11 to 15, 6 to 10, 1 to 5. See, this is the y value. This is the value of y, and before this you will have, this is the value of x. So y value starts from 1 to 100, and you will have these are the x values. So you will have x is equal to, you see like this. For the getting the bigger window, you can close this, no issue. So this is the x value. So we have executed x, y, my circle. So x value is this. Since this value is assigned to this x, and next value is assigned to y. So this is the way you can find the output. Okay. So this is the y value. Now you have this, and if you press first, before that actually you see that you can use CLC command. CLC, I am clearing the window. The window is clear. Now if you wish, see that I have just typed this xy my circle 10 and press enter, then you are getting the value. And if you put colon here, then you will not get the output here. So you have the plot, you have the circle, You have, this is the circle, okay, and you are not getting the value for the x and y because this you are not going to display. You have prevented to echo the x and y values. And if you want to display the x and y value, if you type x and press enter, then you see that these are the x value it has computed. This is the x value it has computed. And if you want to see the y value, then you see that this is the y value it has computed. So this is the y value. So if you don't want to see the output, then you just put the semicolon. So okay. So whenever you have, if you have, if you put the semicolon, you are not getting the output x and y. Okay, this is the important. Now again come to the my circle. Now you can do something like you may not specify the value. See here also colon if you mention the semicolon, and if you don't mention the semicolon, then also it doesn't make any difference. And since I have done modification, I'm going to save it, and just I'm going to run it, and you can still see the output. This means the semicolon you can put at the end or not, it is optional here. In the definition, of the function, you may put semicolon, it is optional. Now see, if you have just one output, if you want only the value for the, say if you want x value only, you are interested with x value only. So you have just mentioned one x value, okay, and then you can save it. Even you have assigned y, and y is not used anywhere else, no problem. So you can save it. Now see, once you are going to execute this, now you are getting the errors because you have only one variable output. So that's why what you need to say, you just mention only one argument, this, and you are going to find the value. This is run. So you should remember. So whenever you have this, you can see. And since you have only one output values x, so don't require to put the square bracket, just omit the square bracket. Now this, so just like the x is equal to my circle r, and save it. You have saved it. Now you can run. Okay. Whenever you have run, then there is no problem at all. You have executed and you have constructed the plot. So what you have learned, that if you have only single variable, then you don't require to put the square bracket. You can just write like this. Now if you don't want any output, and so you don't require to mention the any output variable's name. So just write like this, and you save it, and now you are going to execute it. Okay, since you have not mentioned any variable names, so you can say you don't require to mention x, and then you can say. Now see that you are getting error. Why you are getting error? I have already told you that whenever you don't want to return any value, if you don't have any output variable names, then you don't require to put square. Sorry, you don't require to use the equal to sign here. Means you are not assigning the value to the function any. So you have to omit the equal to sign. So just write only function. If you don't have you think that okay, you are just interested for plotting the circle, you are not interested to get the x and y values, so you just write like this, function my circle r, and you are going to compute. Even within the body, okay, you can compute x and y because you need to plot, you have to compute here. But here you don't require to mention. If you don't want x and y value outside, you don't require to mention any variable. And now see, you save it. Once you save it, and then you run, then you are getting this. So when you have put them equal to sign, it was generating the error. And once if you don't have any output variables, if your function is not going to return any value, you don't require to put the equal to sign here. So these are the things you need to know. One thing is more. So if you write at the end, last you can write and. So whenever you have written and, then also it will work. This function is going to end. So since you are using only one function, then this is optional. And see, you have saved, and first you clear the window, you clear, then you run. Now see, there is no effect. There is no effect. Even still, you are getting the circle. So you have this output circle. So it is not going to make any difference. Even you are going to use and, or you may not going to use and. But remember that you should not use the curly bracket. You should not say that, okay, I will go for the like this. You cannot do like this. It will generate error. So if you run, then it is going to generate error. So these are not required. These will not work. So you need to remove it, and then you have to remove it. Only thing you can do is you can optionally you can put and for the simplicity that you have and the function body. And then if you execute this, then you are getting the output like this. So you have the output. This is the output. Okay. So you have seen the various options here. If you don't have any argument, if you don't want to return any values, then you cannot mention anything. Okay. So you don't require to mention any output here, any output variables here. Now you can remember that if you don't want to enter the value, you can ask the user to enter the radius. If you want that user should enter the radius, then you have to you don't require to take the value my circle r. So what you need to do, you don't require to take the argument here, means you don't require to say this. You just argument list is empty, means you are not getting any value for the radius. So how would you know the radius? So you have to ask the user to enter the radius. So how you can ask the user? You have one built-in function input. You know that you have the input and input, and you need to mention the string name. You can dialog. You can say that in input the radius of this circle. So if you want to display this dialog box, and then you can see. So now say you say that, but you have to mention where you are going to store. You are going to store say variable r. So I'm going to store in the variable r. Then you are going to use r here. So whatever you are going to enter here, the value is assigned to the variable r, and then from r you are getting here, and say you are going to save it. You have saved, and since it don't require, you don't have any argument list, so you just call by writing the name of the function my circle. You just say my circle, and if you press enter, so you have the input, okay, the radius of the circle. So this is the dialog box you have. So you need to enter some value. Say example, I'm going to enter 10. Once you enter 10, then you are going to get the output. So this is the this is the circle of the radius 10. So here input, here you have the typing mistake. Input the radius of the circle, and you can specify the say colon. You can make the space so that it will look like nice. So here it was like this. Then just say my circle, and you are getting the dialog, input the radius of the circle. If you say 100, now I am interested to construct the radius of the, I'm interested for the circle of radius 100, then you can say like this, and you are getting the circle of radius 100. You can see from here to here 100. Now this is the important. So you have, instead of again and again calling, you just ask user what is your interest and input the radius value, and I will plot the circle. So this you have done. Okay. Now if you want, then see that whenever you are going to, one thing is more. Okay. See, if you have, instead of having the 100 points, if you say 10 points only, and you save it, and you just enter the radius of the circle is, say for example 50, and you are making the enter. See, you are getting the figure like this. Why it is so? Because you have just very limited number of points, 10 points. And because of the 10 points, so plot function is going to construct the graph by joining the points actually. So one point is here, one point is here, it is joined by the straight line. From here to here, it is joined by the straight line. So if you have the insufficient point, then it will look like this. So it should look like the circle, then you have to increase the number of points. This is the importance. Okay. So you can change 100, or you can change 100 or 1000, there is no issue. So you have the 100. And once you run with, say, I'm entering the 80, radius of the circle is 80, and you see the output of the circle. Now one thing is that here you see the circle of radius r. You may not be able to see because of the screen. I am able to see because my screen looks bigger. If so, I want that, okay, this particular title should be bigger, or this particular title should be in different colors, so that you can easily identify. So what you can do, you can say circle. Here you can specify the values. So you want some color. Say for example, you want some color which is say red color. I want to mention red. For so for the color red, you can write red, or you just write R. R denotes for the red color, B denotes for the letter B denotes the blue color, M for magenta, like this. So G for green. So I am interested for the red color. Okay, just say, you can see the value, and you have just save it. And then if you run by giving some, say 200, radius is 200, and you will see that the title of the circle, this will be now in the red color. You can see the red color here, but still the font size is less. You can change the font size. So you can say again here, you can modify the function script. You can say sorry, you can say font size. Font size. So font size, what font size you want? Say I want 20 font size, like this, and just save it, and you run it. Enter the circle radius. Say I am going to enter 150, and once you have 150, then you can see here. Now the title of the circle in the some red color and big. Now I think everyone is able to see the circle of the radius r. You can see. So this is the way you can modify, and you can, so that it will be visual, and it should be, you can trace the, actually this is the graphics, and this is the tracing actually. You can do the tracing like this. In the later, when we go for the 2D and 3D plot, we will learn more. Now see that one thing is that here, if you run here, and I'm going to give the, say 200, or radius of circle 20, And here you see that circle of radius r, and circle of radius r, instead of whatever the radius of this circle, it should display like this, like circle of radius 20, this is the 20, so it should be circle of radius 20. So you can mention on like this. So how you do? You can do by specifying the here actually. So you have to group here. See, in the title you have to mention the single string, and if you want to group the strings, then you have to put the square bracket or you have to go for the curly braces. So circle of radius r. Okay. So circle of radius r. Now this is, and how to now you have the variable values r. This is the radius r, and you are going to input the radius r. So but r is the numeric, and you want to change with the string, because here this must be the string, that the argument of this title is string. So how to change numeric value to the string? So you can remember that in the some class we have studied that there are some function which can change, like a string to number or number to string. So the function you may remember that num to str, num to string, and you have the value r. Okay, then you can specify this, and you will see. Now see, circle of radius, this is one string, and num to string, this is the number is r, this is the numeric, and this function is going to change it to the string. So the one continuous string, circle of radius, like this, because square bracket you have, this is just like it, you will show in one row. So circle of radius num to string, this number will be converted to the string, and then you will find the value. Okay, if you save it, you have saved. Now see, CLC, I'm going to, and you want to run my circle. Okay. Is there some error in this? So my circle dot I am line 838 unbalanced bracket. So okay. So you have the unbalanced something, you can see what is the problem. So this is the way you will see that. Okay. So here actually the problem is here. Instead of here you have to mention the, now it will be okay. So earlier we have mentioned the quote before the braces, means so it was treating this whole as a string. Now after the braces means this is one string and this is next, and it will say it will display in one row. Because this square bracket means simply you are grouping the two string, because title takes only one string. So how you can group the number of string to form a one string with the help of the square bracket, or you can put the curly braces also. So this, so here you should not have the code. Now you can save it, and possibly it will work. Now this works. So if you mention, say I'm mentioning 300, so now you will see. So circle of radius 300. Now say that if you change the value, it will be 200, 300. So presently this circle is off and radius of this circle is 300. So circle of radius 300. Like this. Again you can run. You can say I'm 190. Radius is 190. Now see, the circle of radius 190. You can see the 190 here. Are you getting? So see that this is the interactive actually, so that it is understood that okay, circle of radius 190. So you have the circle of radius 190. This is. So this is the way you can make the graph interactive, and the more things you will learn later. So see, we have seen number of variations here. So you can ask the user to input. You can not use any argument. This is the empty argument. You don't require to give the argument. Once function is running, it is asking the user to enter the value. Whatever you are entering, it is taking, and it will. So these are the possible variations we have seen. Okay. So I think we have seen all possible variations in the number of ways you can do this. You may be interested to convert the Fahrenheit to the Celsius. So how you can convert the Fahrenheit to the Celsius? This is also. So this is the function. This is the name of the function. This is the definition. Function Celsius. It is going to return the value in the Celsius. Input is in the Fahrenheit. So this is just variable, and FAHR means Fahrenheit, means input is Fahrenheit, just for remembering purpose. And I have to see, this is the name of the function, means Fahrenheit to Celsius. And just what you need need to write only one statement. Celsius is equal to Fahrenheit. How you can convert? This is the formula. So whatever be the value of the Fahrenheit value, you are subtracting 32, and then you are multiplying by 5 by 9. So 5 by 9 times this. So you are getting the answer. And you are saving by the name F2C. The file name will be F2C. This is. And how you can run? The file name is F2C. And since it takes only one value, which is in the Fahrenheit. Say if you supply 32, then what will have? If you supply 32, then 32 minus 32, 0. 0 times 5 by 9 means 0. So you will get the 0 answer. So you supply 32, you are getting the answer 0. If you supply 212, you are getting the answer 100. So if you are giving the value like 32, okay, and so whenever you have the 32, that time 32 plus 100. So what is the value it is going to evaluate? It is going to evaluate the 0, and you are adding into the this value, so you have the 100. So this is the way that this function returns one value, and that value, in that value you are going to add 100, so the answer is 100. This is also means within the expression you can also call the function. You can also learn. Now you can, instead of the single variable, you can give the vector also, 32 and 200. Now if you, instead of the 1 by 1 matrix, you are going to give 1 by 2, means you have the 2 element. This is the vector of 2 element. Then for the first value 32, what is the value in the Celsius? 0. For 212, what is the value for the Celsius? 100. So 1 by 1 it is going to compute. In this way, if you want to compute the translate from Fahrenheit to Celsius for a list of the Fahrenheit values, then you can specify here. So you can give the vector also as the input. So temp vector, you are assigning this vector, and then F2C, you are calling the function by giving this vector, and whatever be the number of values, for every value it is going to convert into the Celsius. So function is very important. So creation of the function is very important. So till now we have learned how to create the script file, simple script file, and then we have learned that how we can, if you want to go for the modular programming, how you can write the function, how you can create the function in the MATLAB, and how you can use the function just like the built-in function.